Okay, if you know your 8 endings from your first quiz, then it's going to be easy for you to know a few of your 8 endings for your second quiz. So this is going to be 8 endings. All right, and we're only going to mess with the polyatomic ions at corners. We don't have any 8 endings for chromate that you have to know, and no acetate or permanganate. We don't have to know those for us. All right, so let's get started. The first one let's go to is nitrate. The good thing about these polyatomic ions, if you know your 8, then you can know your 8. Nitrate basically is NO2 -1. All of your 8 endings are going to have one less oxygen, but thank goodness they have the same charge. So nitrate, nitrite. All right, let's go down. If this is sulfate, then you can have sulfite. And all the 8s have one less oxygen than their 8 partner. So this would be SO3. Thank goodness the charges are the same. SO2. Now, I don't think you have to know this, but let me see if you can figure this out. What would phosphite be? PO3 with a -3 charge. That would be phosphite, but it's not on your name list to know. Now, carbonate is not on your list either, but I think you're catching on here. Carbonate, in case you have it on a question from your textbook, is going to be CO2 with a -2 charge. All right, now chlorate has a unique naming system. First of all, these are halogens. Chlorine's a halogen, and it has a sort of a running name of that you're going to have to know. And let's see. You know chlorate. So if you're going to do chlorite, it's going to be ClO2 with a -1. That's your chlorite. But we have other polyatomic ions that fit in this category. You also have one called ClO with a -1, just one chlorine, one oxygen, and that is called hypochlorite. Now, hypo is a prefix that means lowest or below. So the least number of oxygen is hypochlorite. Now we can go the other way. We can have ClO4 -1, and it's the highest number of oxygens. And the per is actually an abbreviation for hyper. Hypo you keep, we drop off the high for perchlorate, but it is the highest number of oxygens that these halogens can contain. So you actually have 4 different halogens, polyatomic ions. Now another thing you can do is you can substitute any halogen in for chlorine. You could have a iodate, you could have a iodite, you can have a hypoiodite, or you could have a periodate. Any halogen can fit into this naming system that you have for the chlorines. All right, so once again, if you know your 8s, then you know your 8s. Now your second quiz also includes polyatomic ions that have had hydrogens thrown at them. Now hydrogen is a positive ion. It's just a simple little proton with nothing else carried with it. So if we add a hydrogen to some of your polyatomic ions, it's going to reduce the overall charge by 1. Remember, it's going to reduce the charge by 1. But that's not a problem because you already know what your charges are. And if we throw a hydrogen in front of it, it's going to reduce the charge by 1. Now, one of the first ones you have to know is hydrogen carbonate. So HCO3. Now, since CO3 by itself is a -2, but you throw a hydrogen at it, the overall charge on this polyatomic ion becomes a -1. And its name is hydrogen carbonate. Now, your book may use bicarbonate. I don't use that. It's much easier if you'll just learn hydrogen carbonate. All right? Now, if we go over to, well, let me ask you this. If we threw another hydrogen on here, would it be a polyatomic ion anymore? You'd have 2 positives and 1 negative, and it wouldn't be an ion anymore. So, only 1 hydrogen can be bound to your carbonate. Same for your sulfate over here. You can have hydrogen sulfate with a -1 charge because it'll only take 1 hydrogen and still remain an ion. Sorry, didn't get it right there. But now let's go down here to, well, now that's going to be hydrogen sulfate. And you got hydrogen carbonate. Now we've got phosphate down here. Phosphate that has lots of charges. So to differentiate between the phosphates, we're going to have to talk about how many hydrogens, or use a prefix to tell how many hydrogens we've added to it. So if I add a hydrogen to phosphate, that's going to bring down the charge to a -2. And I need to tell you how many hydrogens. Well, there's only 1, so we use the prefix mono. Mono hydrogen phosphate. Because for phosphate, I can have 2 hydrogens. And that still leaves me with a polyatomic ion with a -1 charge. So this would be dihydrogen phosphate. All 3 of those will have different charges because of the presence and the number of hydrogens that are present. I believe that covers all of your hydrogens that can be added. Why can't we have hydrogens up here? If we add a hydrogen to this, then it's no longer an ion. They would balance out to be a neutral compound.